In Part 8 of the Unit 3 notes, we will be covering Avogadro conversions and two-step conversions. Atoms or molecules and moles can be converted using an equivalency. 1 mole equals 6.022 times 10 to the 23rd atoms. N-dimensional analysis. You should round the final answer based on significant figure rules. Here we have an example of what this would look like. A chemist produces 4.22 times 10 to the 23rd atoms of silver from a chemical reaction. How many moles were produced? We started out with the unit of atoms, so with dimensional analysis we must cancel out those atoms onto the bottom. We are trying to find moles, so moles is going to go on top. Our equivalency here is constant. Moles is always 1, and atoms or molecules is always Avogadro's number, or 6.022 times 10 to the 23rd. So these types of Avogadro's conversions, you do not need to reference a periodic table at any time. Here we need to multiply by 1, which doesn't change our value, and then divide by 6.022 times 10 to the 23rd. So we end up with 0.701 moles of silver. In our checkpoint, we are going to be starting off with atoms of silicon. So we're going to write out 2.0 times 10 to the 12th atoms Si. We're going to write out our conversion factor. The atoms of Si is going to go on the bottom in order to cancel. We're looking for moles of Si, so that's going to go on top. Moles is equal to 1, and atoms is always equal to Avogadro's number, so 6.022 times 10 to the 23rd. Now from here I need to divide in order to get my answer. Now as you plug this into a calculator, it is very important that you put both of these numbers within parentheses. Otherwise the order of operations is going to get mixed up and you are not going to end up with the right answer. If you divide these two correctly, you should end up with 3.3 times 10 to the negative 12th power, and that's moles of Si. For our second conversion, this time we're going in the other direction. So I'm starting with 3.5 moles, and this is phosphorus. We're going to cancel out moles of phosphorus on our way to atoms of phosphorus. Moles is always 1, and atoms is Avogadro's number. So because we are going to atoms this time, our Avogadro's number is going to be on the top. Now again, because this has scientific notation in it, I have to put parentheses around the entire thing. Otherwise, order of operations will get mixed up in the calculator. So I have 3.5 times 6.022 times 10 to the 23rd power. And if I multiply that across, I end up with 2.1 times 10 to the 24th. And that's atoms of phosphorus. Next up, we have two-step conversions. These occur when we are converting between grams and atoms or molecules. That is because we have to convert to moles first. Atoms of different elements are not going to have the same mass. In our example here, a chemist produces 2.93 times 10 to the 23rd atoms of carbon from a chemical reaction, and we are trying to determine how many grams that would be. In order to do this, we have to convert from atoms to moles first. So that's our first stage of the conversion. And once these atoms have canceled out, I can now cancel the moles on my way to grams, the unit I was actually looking for. And here, when we are multiplying and dividing across, because these two numbers are in scientific notation, they must be in parentheses. The 12.01 does not. So if you divide these two numbers and then multiply by 12.01, you should get 5.84 grams of carbon. All right, so now we're going to have a few checkpoint questions where we're going to go through similar conversions. For our first problem, we have 2.15 times 10 to the 22nd molecules of N2. Now you may be asking yourself, why am I using the word molecules here if nitrogen is an element and not a compound? And this is because N2 is another one of those diatomic elements. And because there are two atoms bonded together here, it's considered a molecule. Alright, so I am going to cancel out molecules on my way to moles. So I'm going to have to stop at moles in the middle for each of these. And then once I cancel out those molecules, I then can cancel out moles on my way to grams. We're still going to have N2 at the end. Now the moles is always going to be equal to 1 for both of these. Molecules, just like atoms, is going to be Avogadro's number. And grams we're getting from the periodic table. Now nitrogen by itself is 14.01, but we have two of them here. So this is going to be 28.02. These two numbers have to be in parentheses because they are in scientific notation. So I'm going to divide these two, and then I'm going to multiply by 28.02. And that comes out to 1.00 grams of nitrogen. For our next question, we're starting with 2.5 grams of helium, and we want to know how many atoms that is. Grams is going to be converted to moles first, and then we're going to go from moles the rest of the way back out to atoms. And we can see our units are canceling along the way until we're left with atoms of He. Moles is going to be equal to 1. Grams is from the periodic table, and for helium, that's 4.00. Atoms is Avogadro's number, which again is going to need parentheses when we plug that part into the calculator. So we are going to have 2.5 divided by 4, and then multiplied by Avogadro's number. We have to round for the two significant figures here, so 3.76 is going to become 3.8 times 10 to the 23rd power, and that is atoms of helium. We have one more checkpoint question that we're going to be doing with these two-step conversions, and this is a little different just because here we have water, which is a compound, not an element, but we're going to approach it in the same exact way. So I have 6.15 times 10 to the 24th molecules of water, which is H2O. I picked out a compound that you should be familiar with. From here, we are going to cancel out molecules of H2O on our way to moles of H2O. And then moles of H2O out to grams of H2O. Moles is going to be equal to 1. Molecules is going to be equal to Avogadro's number. And now for the grams. Now normally you could just look up the mass on the periodic table and you would pull it from there. But we have 3 total atoms that are making up this mass. Each of these hydrogens is equal to 1.01, and there's 2 of them. And then the oxygen is 16.00. So we're going to add all of that up, 18.02. And clearly this is a very small compound, so it's pretty simple to add those atoms up. But you would do the same for any other compound. Molecules cancel with molecules, moles with moles, and we're left with grams. These two numbers need to be in parentheses because they are scientific notation. We're dividing these two numbers and then multiplying by 18.02. So if we plug all of that in, we should end up with 184 grams of water. So that concludes all of the notes for Unit 3. As you are preparing for the unit assessment, make sure that you are looking over all the resources that you've had so far. So with our key assignments, make sure that you complete all of the practice assignments and that you resubmit until you end up with at least an 80%. If we've had any labs or virtual labs inside of this unit, such as the Conservation of Mass Lab, make sure that you have completed all of those questions and that if you have any questions about the actual content, you ask me about it. And finally, of course, On our YouTube channel, we have the other content creators which have been linked. So within this unit, there are videos from Tyler DeWitt, Crash Course, Melissa Maribel, and Ted Ed, which have been posted into my Unit 3 playlist. So you can watch any of those videos for additional help as you are preparing for the assessment.